So it's getting closer to the actual exam date for the math method, exam one, exam two. I think I can use this opportunity to tick the box because I didn't get a chance to really look into the 2021 exam two. So let's have a look. Question one, very easy. The period of a tangent function, pi over 2. That is just 2. Boy. Question two, the graph is identical to something else. So basically, I'm just using the log loss. Multiply the arguments, x and 2x. These will be combined into log base e 2x squared, and x is greater than 0, which is option C. A box contains many colored glass beads. Beads or bed. What is this? Anyway, a random sample of 48 items is selected, and it is found that the proportion of the blue colored in this sample is 0.125. So p hat equals to 0.125, which is 1 over 8. So x equals to 48 times 1 over 8. This is my m value, and that is 6. So I'm going to use CAS calculator to find this 95% confidence interval. Let's have a look. Menu, stats, confidence intervals, one props interval. You could enter it like 6, 48, 0.95. Yeah. Control enter. So it's 0.0314 and 2186. So option A is the correct answer. Okay, next. Maximum value of the function. Well, we need to get this graph over the domain from 0 to 2. If we say the maximum value, that is the maximum y value. CAS calculator again. F max, x minus 2 times exponential power x. X from 0 to 2. That occurs at x equals to 2. So when I chuck x equals to 2 into the function to get a y, that's 0. So option B. Okay, next question. Next question, we are talking about this function, f of x equals to x. And we can test each option. F of x equals to f of minus x. This is not true, but minus f of x equals to f minus x. That is true. F of x equals to minus f of x. That is not true. And f of x whole thing squared equals to f of x squared. That is true. So there are two equations holding true. So option C, I suppose. Okay, we can move on to the next one. The probability of winning a game is 0.25, so P equals to 0.25. If Ben plays 10 games, the probability that he will win exactly 4 times. Okay, so that is 10 choose 4, a quarter to the power 4, 3/4 to the power 6. Or you can use binom CDF. The reason why I'm using CDF is because it's just easier for me. We can use the same lower and upper bound, 4 and 4. So it's the same thing calculated by binom PDF. I suppose if I press the buttons correctly, (0.14599). So option A. This is actually a very easy question. It's not a moderate one. It's an easy one. Okay, very doable. Let's move on and look at the next one. Okay, this is something I would like to talk a bit more about it. The tangent to this graph at x equals to 1 passes through the origin. So 0, 0 should be substituted into the tangent equation, and we solve for the letter A. What you can do here is, let's call this yt assigned to tangent line x power 3 minus a times x squared. You have to put this multiplication sign here, plus 1, comma x, comma 1. And then you just solve yt of 0 equals to 0 for a. So a equals to 1. So option B is the correct answer. Not very challenging. So let's have a look at the next one. Okay, the graph of the function f is shown below. Let's say this graph is very likely to be log e of x minus a. So if I take the derivative, dy dx is 1 over x minus a. And the domain for this function is x greater than a, so the derivative also has the same domain x greater than a. Now, if you look at the graphs, I would say it's option E. Just be mindful of the domain. Should be, the same domain. And x equals to a is not differentiable. The gradient does not exist. Okay, question 9. Question 9, be aware for the current study design, the exams could also use this FOG notation, fog notation. This is the overall domain. So I'm going to talk about this, analyze this graph over this domain, okay? And question 10, we can just use the domain of two intersecting domains. So for this thing here, we have x greater than or equal to minus 2. For this thing here, we have x less than or equal to half. So draw a diagram, minus 2, half. So that will give me option D. Before I go back to question 9, what I'm going to talk about is domain of f plus or minus g or f times g is domain f intersecting domain g. If I have domain of f divided by g, that is domain f intersecting domain g. But we need to exclude. We need to exclude something like any x making g of x equals to 0. We need to use backslash, okay? All right, let's go back and look at question 9. So the inner function is x plus 2. The outer function is this thing. So we may say h of x equals to x plus 2 squared minus 4 over this domain. H of x is assigned to x plus 2 squared minus 4. F max h of x, comma x, comma, minus 5 to minus 1. And f minimum is at x equals to minus 2. So I would be calculating f minus 2 to minus 5. So the range should be, let me have a closer look. The minimum, the maximum, doesn't look quite right. So how about I draw a graph? X plus 2 squared minus 4. And given that, minus 5 less than or equal to x, less than minus 1. Okay, so I think the minimum, let's see where I went wrong. This is h, not f. Yep, from minus 4 to 5. And notice on the graph, when x equals to minus 2, the y value minus 4 is achievable. It's a solid point. And here, we should have the maximum value, which is 5. Okay, so minus 4 to 5. So option E is the correct answer. Okay, very doable. Let's look at the next one. Question 11, integral Split the integral into 3, 0 to a, f of x dx, plus 0 to a, 2 dx. So the first bit is just 3k. The second bit is 2a. Option A, very simple. Okay. For a certain species of a bird, the proportion of birds with a crest is known to be 3 out of 5. So p hat is a random variable representing the proportion of birds with a crest in a sample size n. Standard deviation of p hat less than 0.08, so we can just go for 3 out of 5 times 2 out of 5 divided by n. That is the formula for the standard deviation of p hat less than 0.08. And we can use the CAS to solve for this n value. If I'm using my CAS calculator, I would say solve button, square root 0.6 times 0.4 divided by n, less than 0.08 n. So n is greater than 37.5, but n has to be a whole number. That's why it's 38, option D. Very standard question. Next. Question 13, you need to find the average rate of change over the first 12 months. So you calculate f of 12 minus f of 0 divided by 12. And if I'm using my CAS calculator correctly, let's have a look. Let's say f of x equals to 2500 times 1.004 to the power x. And F12 minus F0, 12. So it's closest to $10.20. So option B. Okay. Instead of flicking back and forth, I'm going to talk about the next question, which is an average value question. So the question says the average value of cosine kx minus half pi. Basically, it's 1 over pi, integrate from 0 to pi, cosine k times x minus pi over 2 dx equals to the average value of sine over the same interval. So you'll be able to get something along this line, okay? And a value of k, if you solve that, you'll be able to get a k equals to 0.5 or 1. And the only available option is egg, e, half. I mean, this is a very nice question where you could also tackle it by hand. But to be honest with you, I would say if you're gonna solve this equation by inspection, you have to sort of realize 2 over pi is like 1 over pi over 2 something, okay? So that is question 14. Okay, let's have a look at the question 15. Question 15, 4 fair coins are tossed at the same time. The outcome for each coin is independent of the outcome for any other coin. Fair coin, head, half, tail, half. There is an equal number of head and tails, given that there is at least one head. So let's say H, number of head, is binomial 4 coins, half. So if there is at least one head, equal number of head and tails, so H equals to 2, T must equal to 2. So H equals to 2. Basically, I'm getting a binom PDF 4 half 2 divided by binom CDF 4 half 1 4. I can just enter this into the CAS calculator and get the answer straight away. So the answer is 0.4, which is option D, dog. Moving on. Okay, this one is an interesting one. Cosine x equals to 3 over 5. X is in the fourth quadrant. 3, 5. This is minus 4. This letter is x. So we have sine x equals to minus 4 over 5. And the sine squared y equals to 25 over 169. Y is also in the fourth quadrant, quadrant 4. And realizing this is 5 over 13 closing squared. And sine must be negative. So it has to look like this. This is minus 5. This is 13. This is 12. Just recognize the simple whole number Pythagorean triads, okay? This is the y. So cosine of y is going to be 12 over 30. Eventually, when you add them up, minus 4 over 5 plus 12 over 13. That is a 65 here, and this is minus 52 plus 60. So it's 8 over 65, I suppose. Option A. Very simple question. Okay. Discrete random variable x has a binomial distribution with a probability of success of p equals to 0.1 for n trials. N is greater than 2. If the probability of obtaining at least 2 successes after n trials is at least 0.5, then the smallest possible value of n is, we would like a binom CDF n 0.1, 2 to n. We would like this thing to be greater than 0.5. So we sort of need to use trial and error, because we have limited number of options from 15 onwards, okay? What I'm going to do is I'll type out binom CDF n, 0.1, 2, m, and I'm using n equals to 15. It's not yet 0.5. Let's try 17. Yeah, it's greater than 0.5. How about 16? For 16, that's less than 0.5. Therefore, the smallest value of n is C, 17. Okay, question 18. I think after a couple of years, with this sort of a slider question being introduced to the recent 3 or 4 years master exam, we are now getting more used to it. So the idea is that there are two functions. F of x is a cubic, and g of x is product log function. And the maximum number of solutions for the equation x fx minus k equals to g of x. So this is a translated graph. And this k can be greater than 0, can be less than 0, can be 0, okay? So we just see, okay, the different values of k will have some sort of a effect on this one. And we have g of x here. Now, I'm going to demonstrate a slider use on my CAS calculator. First of all, you can see I'm still within 1.9, 1.10, 1.11. So it's still within the same problem. Therefore, I'm going to define f of x equals to 2x minus 1 times 2x plus 1 times 3x minus 1. And then I will define g of x equals to x times natural log of minus x. With these two functions defined, I insert another graph. Now I will say fx minus, let's say k1, and create a slider for k1. The reason I'm using k1 is because I don't want any variable clashes with the commonly used letter k. And the next thing I'm going to plot is g of x. And I can just zoom in a little bit. Now you can see k is 1. Okay, no solution. If k is 0, 1 solution. You can click, right click, hover your cursor here and press Control menu. That is right click, Control menu button. Setting, and set the step size, let's say to a smaller value, 0.1, so you can see the small increment and the small changes. Okay, now see, smaller changes. So far, it's still intersecting, the two graphs will only intersect once. Now, if you push it roughly here, you can see somewhere here, the graphs will touch each other somewhere. And they intersect this at the second place. So these, we can call it two solutions. So at some stage, you can see there are 3 solutions, but it's impossible for the 2 graphs to have 4 intersections or 4 solutions. So still 3 solutions. Okay, so it's roughly here. Another point where we can get just 2 solutions. They touch once, but they also cross each other once, okay? So overall, I would say the maximum number of solutions will be 3, okay? All right, so that's pretty much what I need to discuss, the intersecting graphs. Just be aware if you ever ask this sort of question, like, for example, for what value of k or what values of k will the 2 graphs have exactly 2 intersection points? Well, that means they have to have some sort of a common gradient. Like at this point, you can equate the 2 derivatives. Say derivative f of x minus k. See, this k letter is not influenced. Comma x equals to derivative g of x comma x, something along this line. And you probably can solve 2 equations. That and fx minus k equals to g of x because they just touch each other, x comma k. But the cast does not solve it. So we may have other possible techniques to tackle these sort of questions, okay? Anyway, that's just some further discussion. Let's move on and look at question 19 and 20. Okay, which one of the following functions is differentiable for all real values of x? All of them have a joint x equals to 0. So we sort of want f of 0 minus equals to f of 0 plus, and the derivative f0 minus equals to f0 plus derivative, okay? So if you look at last one, when I take the derivative f dash of x, you will get a 4, and x is less than 0. For the next one, you bring down the 2x plus 1 to the power 1, and multiply by the inner derivative. And should I write x greater than 0 or x greater than or equal to 0? That is the definition of differentiable, or we call it smoothly joint at x equals to 0. So we must make sure if it's smoothly joined, they must have the same gradient from both sides. So 2 times 2 times 0 plus 1, if you chuck in 0, that is indeed 4. That's why we use x greater than or equal to 0. So the gradient function is also continuous. And if you check the y values, like this is 0, this is 0, 1 equals to 1, okay? So that's why option E is the correct answer. Okay, question 20. Let A and B be the 2 independent events from a sample space. We have probability A, probability B, probability A plus B equals to 1. And we want to find this joint probability, probability A dash union B. I'm going to use 2 facts. 1, if A and B are independent, then the complementaries A and B dash are also independent, as well as any other combinations. For example, we know probability A times probability B equals to probability A intersecting B. And we could also say probability A dash times probability B dash equals to probability A dash intersecting B dash. That's what I'm referring to. If A and B are independent events, their complementary events are also independent. And you can find all other combinations like A with B dash or A dash with B. These equations will always hold true as long as the original 2 events are independent. So the next thing I'm going to say is probability of A dash union B is the 1 minus the opposite. The opposite of A dash is A. The opposite of union is intersection. The opposite of B is B dash. This is how I tackle the question. Then you get a 1 minus probability A times probability B dash because A and B are independent. So are the complementary. A and B dash will also be independent of each other. Then you say 1 minus probability A, that's P, and a probability B dash is 1 minus P squared. Therefore, you have 1 minus P plus P to the power of 3, which is giving you option D, all right? So that is a very, different question. But now, I think you should be fine. After you realize A and B are independent events, the complementary events are also independent. So that's my discussion to the 20 multi-choice question. Remember, from 2024 onwards, there will only be 4 options for each multi-choice questions. Okay, question 1, extended response questions. I'm going through these questions relatively quickly. Basically, you have a rectangular sheet of cardboard with width h centimeters and the length 2h centimeters, okay? This one should be, the normal font, not italic, the number. Anyway, I just bought that. The sides of this sheet cardboard are then folded up because you cut the 4 corners. So what you can say is, this bit is h minus 2x because you cut the 2 corners. This bit will be 2h minus 2x. And eventually, the height, once you fold these 4 faces up, will be x. A box is to be made from a sheet of cardboard with h equals 25. So the volume, V box of x equals to x times h minus 2x times 2h minus 2x first. Then your h is 25. So you have x times 25 minus 2x times 15 minus 2x. You can just take out the common factor. So you have 2x here, 25 minus 2x, and 25 minus x. And that is a show that question. State the domain of V box. Now you need to look at the question. V box is greater than 0. So if you think about the shape of this cubic, you have a 0 here, and 25 minus 2x is equal to 0, so x equals 12.5. And also 25 minus x will give you 25. This is a positive linear. This is a negative. This is a negative. So multiply together, you will get a positive cubic. So you are expecting some sort of a cubic graph like this. But to make sure the V is greater than 0, you have to select this part. So it's from 0 to 25 over to exclusive. And the next part, C and D, very standard Year 11 method question. Find the derivative V box, calculate the maximum possible volume of the box, and for which value of x this occurs. So 1 mark, 3 marks. So we say V box dash of x equals to something. Then we can say V box dash x equals to 0 and specify the domain. And x equals to something, V max equals to V of something, gives you some maximum volume, etc. Okay. If you're moving on to the extended response question part, you can press Control Up and bring in a new problem to separate out the variables. Now the question has the first volume. We define it as V1 of x. Okay, so we find the derivative. So this is a derivative, and we may want to use the simultaneous equations. So solve, curly bracket, this equals to 0, comma, v equals to v1 of x, comma, v, given 0 less than x less than 12.5. So actually you will get this value and this value only, because when you solve a quadratic equation, it will give you two pair of points, coordinates, but we just need the positive volume and the corresponding value of x, okay? And don't drop out this negative. If you drop out this negative, it's not the right x value, or otherwise you say 25 times 3 minus root 3, or just copy the string, okay? So that is minus 25 times root 3 minus 3 divided by 6. And the maximum volume is 156.25 root 3 divided by 9 centimeter cubed, okay? All right, let's move on. And back in 2021, I suppose this was a very generous 3 marks question. Okay, waste minimization is a goal when making cardboard boxes. Percentage wasted is based on the area of sheet of cardboard that is cut out before the box is made. It's based on the area of the cardboard that is cut out before the box is made. So if you waste 4 corners, these 4 corners will be cut off. X equals to 5. So each corner is like 25 centimeters square. So area cut equals to 100 centimeters square. Area original, it's based on the area, not the volume, okay? So we know this is 25 centimeter. That's the width, and that's the length, 50 centimeters. So 50 times 25, which is 1250 centimeter square. So percentage wasted, that means the percentage of area of material wasted is 100 divided by 1250 times 100%. So that will be 1/8, I suppose. Let's double check with the CAS calculator. 100 divided by 1250. Yep, it's 8%. Okay. Now consider a box made from a rectangular sheet of cardboard where h is greater than 0. So we no longer deal with a specific number. We are using v2 x equals to 2x. Actually, we should say x times h minus 2x times 2h minus 2x. Okay, or you can say 2x times h minus 2x times h minus x. And the domain restriction, think about the graph again. This must be 0, this must be half h, this must be h, but we're still choosing v2x greater than 0. So the domain is going to be greater than 0, but less than half h, okay? And then we still replicate the previous part to find the maximum volume, but this time we say let v2 of x equals to, let's just write it as 2x h minus 2x times h minus x, okay? Using v2 dash of x equals to 0 and v equals to v2 of x. X must go from 0 to half h. We get x equals to some number, v max equals to some expression. So you can use your CAS calculator. v2 of x is assigned to 2x times h minus 2x times h minus x. And solve v2 of x equal to 0x. Now, how do we distinguish between these two values? Well, I think it's very easy because you can just chalk them into your CAS. Which one gives you a positive volume? It's the second x value giving you the positive volume. So you have to use this value here and get this volume, okay? So you can write it down now. Okay, I think that's the second last part of the question, which is also a very straightforward question. So just be careful with the details. Now consider making a box from a square sheet of cardboard with a side length of h. So draw a diagram. So you cut in the corner x, 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 x. Total length of each side is h. So if you fold the 4 edges, this is something you're going to form. And you are forming a smaller base. which is h minus 2x, h minus 2x, okay? And this is x. So the V3, this is the third box we are talking throughout the question. That is x times h minus 2x times h minus 2x squared. Now, it is interesting to look at this cubic function. Linear, square, that's a cubic. Draw a graph. It's cutting through 0 here, and this is a repeated vector. So you have half h here. This is a rough shape without any domain restriction, but because v3x must be greater than 0, your x is still between 0 and half h. And think about this domain restriction physically. You can't really cut the corners more than half of the length here. Otherwise, you're just cutting one paper into 4 smaller papers, okay? So this is the graph. And I would like to show at this x value, it gives me the maximum volume, okay? So how do we show this thing? Well, first I would say you need to use the derivative. For show that question, I would try to get the explicit derivative expression. Then we can verify this thing here for the nature of the stationary point, okay? Using second derivative. So I'm going to say v3x is x times h minus 2x squared. The derivative v3 of x is this guy here. So you can jot it down, but don't include x equals to half h itself because that gives a 0 volume. It is not part of the domain restriction, okay? So the only solution you get must be x equals to h over 6. And yep. Next thing I'm going to do is I take the second derivative to check the concavity near this particular value. So you can see this result is a negative number, minus 4h, which is less than 0, indicating a concave down curve. That's how I would attempt this question. So let's have a look at my writing space. Okay, so that is part G, all right? Formulate a new function for the scenario, take the derivative equal to 0, and show how you solve this equation. And finally, verify this concavity thing, justify the nature of this stationary point. Don't forget to reject this value, okay? Okay. 4 rectangles of equal width are drawn and used to approximate the area under the parabola y equals to x squared from 0 to 1. The heights of the rectangles are the values of the graph at the right endpoint of each rectangle as shown in the graph below. I think in the current study design, trapezium method will be a bigger focus. But state the width of each of the rectangles shown above. Find the total area of the 4 rectangles and find the area between y equals to x squared, the x-axis, and the line x equals to 1. So the width is just 0.25 or a quarter. Total area of the 4 rectangles. So it's a quarter times f of a quarter plus a quarter times f of half plus a quarter times f of 3/4. It's this point here. And a quarter times f of 1. So I'm going to use, actually I should say let f of x equals to x squared because the question used only y equals to x squared rather than a defined function f. And the next thing is find the area between the graph 0 to 1 x squared dx. That is 1/3 x to the power 3 from 0 to 1, and that gives you 1/3, I suppose. Okay, so I need to use my CAS to figure this out. So let's say f of x is x squared, a quarter times f of a quarter plus f of a half plus f of 3/4 plus f of 1. So pretty much that's 15/32. By the way, if the question said using trapezium estimate, then you can modify your working as follows. This is the answer to the original question, okay? 15/32. So what I'm saying is, hypothetically, if the question says use trapezium estimate with 4 strips to estimate the area under the curve from 0 to 1, then you can type it like that. You start with your beginning f0 and twice this much, twice this much, twice everything in the middle. The first and the last term will only appear once. And you might want to use 1 minus 0, 2n, 2 times how many pieces, how many trapezia you have. So that will give you 11/32, okay? Hypothetically, okay? An annotation here could be further modified. Trapezium estimate. Okay. The graph of f is shown below. So you can see the graph f actually, it doesn't specify the rule, but we want to approximate -2 to 2 using 4 rectangles of equal width and right endpoint of each rectangle. So firstly, we need to get the boundaries. And 4 rectangles, right endpoint. It's this thing. It's this thing. And the next part is a bit interesting because now the next right endpoint is here. Can you see my dots here? And here, okay? So basically you want to find the sum of these 4 rectangles, but this is like +6. This is like +2, so 1 times 6 is +6. And this bit is a -4, and this bit is -6 because 1 times -6. So altogether, when you add them up, it would be 8 minus 10. That is -2, okay? So this is what I'm going to say as the answer for the original question. Also, I would like to make a point here. This thing is the total signed area, okay? So like you can see, originally this chunk is a positive region, this chunk is a negative region. That's why you do expect some sort of compensation happening, okay? Again, in regards to the current study design, we may want to use approximate a -2 to 2 f of x dx using trapezium estimate of equal width 1 unit. Well, if that's the case, let me just put that away for a moment. And let me just get a duplicate. I'm not going to spend too long going through this further discussion thing, but I'll just mention some important ideas here, okay? Okay. So here is a replicated diagram. And if there is a similar variation, hypothetically on the exam paper, I would say, okay, this is one trapezium. The second trapezium. Okay, the next one is not quite a trapezium, I would say, but we can still draw it in the shape of a trapezium. Yes, this is still a trapezium shape, but you will notice at x equals to 1, the y value is a negative value, okay? And also, I'll try to draw this one in a nicer format. So can you see the four trapezia I draw here? So the calculation will then be, this is f minus 2, this is f minus 1, this is f of 0, this is f of 1, this is f of 2. So basically, we still apply that formula, say 2 minus negative 2 divided by 2n. There are four pieces, four parts. 1, 2, 3, 4. But for four parts, you have 1, 2, 3, 4, 5, five values. So what you say is the first value is f minus 2, which is 4, plus 2 lots of f minus 1, which is 6, plus 2 lots of f0, that's 2, plus 2 lots of minus 4, and then plus the last y value itself, just one lot of minus 6. And that's how you could obtain an answer using the trapezium estimate, okay? So that's my further discussion to a possible variation of this question, okay? Okay, most interesting part. Part of the graphs of y equals to x squared and y equals to root x are shown below. Find the area of the shaded region. So basically, I'm using integral from 0 to 1, root x minus x squared dx. If you're using your CAS calculator, I suppose you get an answer of 1/3, okay? Just 1 mark, no need to use any, by hand calculation or whatsoever, okay? It is indeed 1/3. Now the graph y equals to x squared is transformed to the graph of y equals to ax squared, where a is between 0 and 2. So a is a positive value, but find the values of a such that the area defined by the regions bounded by the graph of y equals to ax squared and y equals to root x, and a line x equals to 0 and x equals to a, x equals to 0 and x equals to a, is equal to 1/3. If you answer correct to 3 decimal places. What you could say is now, for example, if you have this y equals to root x, or we already established one particular value, which is y equals to x squared. Well, definitely a equals to 1 is an answer, because you can see about when a equals to 1, yep, the area is 1/3. Okay, next thing is if I dilate, let's try to gray this out. Yep, lighter. Say I have, if a is something, let's say if a is something between 0 and 1, then I may well get, let's say, this is 1. So a is less than 1. This is a. I may get a chunk of area here. So one possible case is 0 to a, and then you say, oh, root x minus a times x squared dx equals to 1/3. And you may want to solve for the a values, okay? So you could say solve integration 0 to a square root of x minus a times x squared dx equals to 1/3 a. So you get a 0.77 something, and a equals to 1. That's one possibility, 0.77, a equals to 1. But there is another possibility. Another possibility is when a is slightly greater than 1. If a is slightly greater than 1, then you sort of dilate this graph like this, okay? So this is y equals to ax squared, and a is greater than 1, but still less than 2. Then you'll be expecting some sort of intersection here, and a is greater than 1, say here. So there are two regions. That's why the question was saying region, bracket S. So the sum of these two regions will equal to, for example, 1/3. Or you could say root x equals to ax squared. So 1 over a equals to x to the power of 3 over 2. And x equals to 1 over a to the power 2 over 3, something like that. This is where the middle intersection is. And then you form an integral equation like a 0 to 1 over a to the power 2/3 root x minus a times. It's like x equals to a here. So we put an a here. And the second integral is the other way around, ax squared minus root x dx. So you would like this whole expression equal to 1/3. And now is a good time to use the CAS calculator. So let me show you what's happening here. Solve 0 to a to the power negative 2 over 3 root x minus a times x squared dx plus shift plus a to the power negative 2 over 3 to a times x squared minus square root of x dx equals to 1/3, comma a, between 0 and a and less than or equal to 2. So you get another value, a equals to 1 or a equals to 1.13 something, okay? So totally there are 3 solutions, but this question was like a 4 marks. So you really have to come up with this case. And if you look at the assessment report, it was commented that many students omitted the second possible case. But in fact, I came up with this method 3 years ago. After I saw this paper, irrespective of whichever case, you might just want to go for 0 to a and put an absolute value here. Square root of x minus a times x squared dx equals to 1/3, comma a, given 0 less than a less than or equal to 2. This will directly give you all 3 values without any specific discussion into the case, because we don't know if the intersection is outside x equals to 1 or inside x equals to 1. And we can just ignore whichever is above or below. Just make an absolute value between 2 curves, irrespective of 2 curves intersecting or not. Okay, so this may be a quick shortcut, but cutting this corner, well, not many people would be able to come up with this cutting corner method. Okay, so let's just go back and look at the rest of the exam questions properly. Okay, 4 marks question, interesting case. All right, question 3, state the maximum domain and the range of Q, find the equation of the tangent, find the equation of the line perpendicular to the graph of Q, and x equals to 2, passing through the point -2, 0 whatsoever. Okay, so I'm going to just apply my CAS calculator again. Insert a new problem. Q of x is assigned to natural log of x squared minus 1 minus natural log of 1 minus x. Domain Q of x, comma x, less than -1. And if you want to look at the range, just look at the Q of x. Okay, looks like all real numbers. Equation of tangent, yt equals to tangent line. Q of x, comma x, comma -2. So y equals to -x minus 2. And a perpendicular, y normal equals to normal line, Q of x, comma x -2, x plus 2, okay? So these are the working through to the first 4 marks, very straightforward. And let's have a look at the specific parts into it. Okay. That p of x equals to e to the power minus 2x minus 2 e to the power minus x plus 1. Explain why p is not a one-to-one function and find the gradient of the tangent to the graph of p at x equals to a. Well, basically, we need to define this function. P of x is assigned to exponential minus 2x minus 2 exponential minus x plus 1. And if you draw a graph here, P of x, this is how it looks like. It's a many-to-one, okay? It's a many-to-one function, and it has a horizontal asymptote at a y equals to 1, okay? So for some values of x, two values of x, it has a one y value. And gradient of tangent at x equals to a. This is how you could do the question, okay? Just be aware you can put an a here, then an a here, so everything is in terms of a. But if you put an x here and an a here, then you get a 0, okay? Make sure you have consistent letters here and here, all right? Okay, so that is first, first 6 marks. Very easy. Okay, the diagram below shows parts of the graph of P and a line y equals to x plus 2. The line y equals to x plus 2 and a tangent to the graph of P at x equals to a intersect with an acute angle, theta between them. So let's say if I had a tangent line over there, that's one particular point. Find the values of a for which theta is 60 degrees. Give your answer correct to 2 decimal places. So basically, that is one possible case. Theta equals to 60 degrees. And so what I'm trying to say is now, because this is x plus 2, this is a 45 degrees, okay? When this is 60 degrees, this is also 60 degrees. That means that this angle has to be, 75 degrees. So the gradient of this line must be tangent 105 degrees or negative 75 degrees, okay? So one possibility is P dash of A equals to tangent 105 degrees, okay? And we can solve for the value of A. And the question says the values. That makes me consider, all right, could I find another possible graph, let's say another possible tangent to make us 60 degrees between the two lines? Well, yes, there is another case. Because when you put a line here, now it's not quite 60 degrees, but if you try to make it smaller, flatter, yep, this is another possible case you could get a 60 degrees. Like this is 60 degrees. This is 45 degrees. So this is 120 degrees. 120 plus 45 is 165. So in a triangle, here is 15 degrees. You may also get a 165 degrees. So you also have P dash of A equals to tangent 165 degrees. And that gives you another A value, okay? So basically that's another possibility. So this is something I'm going to use. So that equals to tangent 105 degrees for A. This is one possible value. And if I change this to 165 degrees, this is another possible value. So 2 decimal places, we say minus 0.67. Yeah. And another A value is like minus 0.11. Okay. All right. Okay, so this is Part E? Well, I'm thinking if we could use the difference of two angles to get, yeah, it is technically possible. Like you might want to say absolute value tangent inverse of P dash A, subtracting a 45 degrees equals to 60 degrees. Does that work? Because it might well be some sort of a negative angle or whatsoever. Let's have a look at this CAS calculator approach. I'm always curious to see other possibilities. Arctan. Don't need this bit. Don't need this bit. Absolute value arctan minus 45 degrees equals to 60 degrees, comma A. That just give me that. And if I have, what about the other way around? Okay, so it's not like you're taking the shortcut. We have to discuss the two cases. Okay, it's not gonna be how it works. Now, just use the diagram to generate two suitable triangles and get these two values. Okay, the last part of the question wants you to find the x-coordinate of the point of intersection between P and y equals to x plus 2. So you can look back at this diagram. So I can choose page layout ungroup. Now here is the diagram. Here's x plus 2. Yep, and we would like to get the x-coordinate intersection. Try to get more decimal places for the later calculation, all right? So you say minus 0.750. You do have to specify this 0 here. But for the actual integration, I would say it's one triangle, analyze graph, integral graph from here, analyze graph from here to minus 0.7504032. Okay, so that's one part. And then we can go for analyze graph integral. Now I click into this function, but instead of using, actually, I can click into this point up to 0. And then eventually I can add these two up. So let's do a page layout, select layout, side by side. Okay. So it's 0.78075 plus 0.25735. Okay, so the answer is 1.0381 something. So just truncate it to 1.038. Okay. All right, let me get back and write down the working. Don't forget about the x. That's what I'm going to write. Okay. 3 marks. Fair 3 marks. Okay, that was also another famous question. A teacher coaches their school table tennis team. The teacher has an adjustable ball machine that they use to help the players practice. The speed measured in meters per second of the balls shot by the ball machine is a normally distributed random variable W. Mean is 10 and standard deviation 0.8. determine probability W greater than or equal to 11 correct to 3 decimal places. So probably use norm CDF 11 infinity 10 0.8. Okay, and I find the value of A in meters per second, which 80% of the ball speeds are below this value. So if you draw a quick diagram, 80% below this K. So this area is 0.8. So K equals to inverse norm 0.8, 10, 0.8. Okay, so let's get back to the CAS calculator. And it's 10 point, K value is 10.7 meters per second, okay? Correct to 1 decimal place, all right? And the next thing, let's have a look at the next page, next part. The teacher adjusts the height setting for the ball machine. The machine now shoots balls high above the table tennis table. Unfortunately, with the new height setting, 8% of the balls do not land on the table. So this is my p value, 0.08. P had to be the random variable representing the sample proportion, 25 balls. That is n equals 25. So the expected value of capital P hat is just P, which is 0.08. The standard deviation of P hat is square root of P, 1 minus P, divided by n. So that is 0.08 times 0.92 divided by 25. And you have to calculate this, simplify this answer. So if you chuck into your CAS calculator, you will get root 46 divided by 125. Okay. Use the binomial distribution to find the probability he had greater than 0.1 correct to 3 decimal places. So first I would say let X be a binomial distribution, n equals to 25, p equals to 0.08. Now your probability of p hat greater than 0.1 equals to probability of n p hat greater than 0.1 times 25. So n times p hat is your x, the binomial variable, greater than 2.5. Basically, you need to use binom CDF 25, 0.08. And it can't really take the value 2.5. It has to start with 3 for discrete value, 3 to 25. And let's use our CAS calculator. So this is what you're going to get, like 0.323, something along this line, okay? And if you use your CAS calculator, you might want to use 2.5 here. It only works on KI. For Casio class pattern, you have to use 3 here rather than 2.5, okay, for the lower bound. Okay, let's move on. The teacher can also adjust the spin setting on the ball machine. Now it's a variable x. Find the maximum possible spin applied by the ball machine in revolutions per second. Well, the maximum spin will be 50, okay? This is talking about x max, rev per second, okay? Find the median spin in the current study design. Not in 2023 to 2027, but they could ask, but could ask 50th percentile, okay? So this is just talking about, integrating from 0 to m, because the effective domain has a 0 as the smallest value. F of x dx equals to 0.5. And then you get the m value. And I round it to 1 decimal place, something like that. Notice the question, the probability function spans over 2 effective domains. So you do need to check whether or not this one already accumulated 0.5 area under the curve, under the first part of the curve. What I'm going to say is I will assign let's use a different problem. f1 of x is assigned to x over 500. Okay. And f2 of x is assigned to 50 minus x divided by 750. So if I integrate 0 to 20, f1x dx, that is not yet 0.5. So I'm pretty sure the median will lie within the second part of the domain, 20 to 50 somewhere. So you could say, all right, plus f1x dx from 0 to 20 plus 20 to m, f2 of x dx equals to 0.5. And solve this equation for m. And remember, the m has to be within 20 to 50. So this is the exact value, and this is the decimal value, 22.6. Okay. Keep this exact value later. Okay. So we'll have a look at the next part. Okay, next. Find the standard deviation of the spin in revolution per second correct to 1 decimal place. So I think I would need to demonstrate some calculations here. One, the EX is your mu value, which is the integration of 0 to 20 x times x divided by 500 dx plus 20 to 50 x times 50 minus x 750. Okay. And the next thing is the standard deviation of x is sigma. It equals to the square root of the same calculation here, except for these parts. Because I need the mu value. It's x minus that mu value square, multiply each part of the probability function. And then I'm able to get some value here, approximate to some value correct to 1 decimal place. So what I'm trying to do is go back and look at what I already typed here. I just need to borrow the right-hand side. Now I change the upper limit to 50, x times f1 of x times f2 of x. So 70 over 3 will be the exact mean value. Okay? And then I would chuck that into the formula. Bring this down, put a bracket here, minus 70 over 3 squared. Put a bracket here, minus 70 over 3 here. So you get a 950 over 9. Take a square root of that and round it to 1 decimal place. That's 10.3, okay? Root 950 over 9. And that's approximately 10.3 revolution per second. Okay, so that's how I would attempt this question. And I have a reason why I'm not defining the whole function as a hybrid function. Because when you define the function like this, f of x is assigned to x over 500 from 0 to 20. And then it's 50 minus x divided by 750 from 20 to 50. Okay, yep, you can do it like this, 0 to 20, x times f of x dx. Is that right? Let me have a look. I probably have defined something incorrectly. Nah, 50. Yeah, that's a problem. So you can see now the output is a very ugly expression. It doesn't quite give you, the desired exact value, even if we can recognize this is 23 and 1/3 exactly. Well, lucky thing is the question only requires the decimal approximation, not the exact value. Okay, so that's why I'm not using, I'm not going to use the hybrid function form in this particular instance. You can see now for the variance, it doesn't give the value straight away. You have to manually press Control Enter and get this value and take a square root of that value. Okay, yep, but that is also a valid way you could approach on your own CAS calculator. Okay, so I need to move on to the last part. And the last part back in 3 years ago, back in 2021, it was deemed a challenging question. And in 23, there was a similar question dilating the mean value from an old variable to another variable to a new variable. G of x equals to a times f of x over b. So basically, if you think about the shape of the graph, I'm using blue color to represent what happens here. This is the distribution for the f of x is in blue, okay? And we know the median was 21.6, I suppose, or 22.6. 22.6 something, okay? And we would like to adjust the spin setting to get a new function. So the median will now be 30, okay? It's sort of indicating, well, you need to stretch this graph in some way. You need to stretch this function some way by a dilation. But when you stretched this triangle horizontally to here, the area will be larger than 1. Therefore, you need to dilate. You need to dilate this new graph vertically. So if it's wider, then it has to be shorter. Okay. Old median was 5 times 10 minus root 30. New median is 30. So dilation factor B from the y-axis. This is y-axis, this is x. B equals to the new value divided by the old value, okay? And you may want to get a decimal approximation of this value. Say it's 30 divided by 5 times 10 minus root 30, square root 30. That's 1.33, correct, to 2 decimal places. The other thing is to keep the triangle area equal to 1. A must equal to 1 over B because you elongated by a factor B horizontally. Then you need to divide the area by B, okay, to maintain an area of 1. So that is 5 times 10 minus root 30 divided by 30. And it's approximately equal to 0.75. Okay? So that's under the argument of dilations, but you do have the possibility to do integral equations. The integral equation method is just a longer method, okay? So what I'm going to show you this. It's doable by CAS as long as you use the f1 and f2 separately. So what you can do is now, one equation, you could say this is equation 1. If you want the median to be 30, well, just put a 30 here. And you put an a times f1x over b here. And a times f2 of x over b here. And don't forget, this should be a 20b and a 20b, okay? Because all the x values are supposed to be dilated by a factor b, okay? So that is the first equation. The other equation I'm going to use is the total area equals to 1, but you have to use 50b instead of 50. So that is the second equation, and you can see a times b equals to 1. And then solve these two equations up. By the way, this is equation 2. Equation 1, delete this one. Delete this one. I can't define equation 1 as 2c. I must define equation 1 and equation 2 distinctively. So then you solve equation 1, equation 2 for AB. There are two possible values, but you don't want this value, okay? You don't want this value because if you're using this value, it's not, it's not possible to get a median of, 30, okay? For example, you may want to put this back and double check, okay? So that is the only possible pair of solutions. Okay, let's look at the last question. The last question was a really good question, except for the very last part. Personally, I don't like the very last part. It's a bit ambiguous. Find the greatest possible minimum value of GA. This one. Part of the graph is shown below. Sine half x plus cosine 2x. State the period of f. So you can see the period of this thing is 4 pi. The period of this thing is pi. We take the least common multiple, which is 4 pi, okay? And state the minimum value of f correct to 3 decimal places. Basically, you just need to sketch this graph and identify the minimum and find the smallest positive value of h for fh minus x equals to f of x. Okay, so let's define this function. And yep, that's true. If it's 2 pi, it's not true, okay? So the smallest period is 4 pi. And if you plot this graph, and between 0 to 4 pi, minus 4 pi, yeah, the maximum value is, the maximum value in this case is 2, but the minimum value, I suppose, is minus 1.722. Minus 1.722, okay? 3 decimal places. And the smallest positive value of h. H minus x equals to f of x. You can try h equals to pi. It's not true. 2 pi, true. Sometimes you might try half pi, but it's not true. 3 pi over 2. So this is a common strategy. You can type out the equation, and given that h is the parameter equals to a multiple of pi, okay? So the smallest positive value of h is 2 pi. Well, I'm not entirely sure how you're going to solve this, but would the cat solve this one? I'm not sure. So you can sort of see, if you want fh minus x equals to f of x, seems that I need to equate the sine terms and equate the cosine term. But then, for example, if you solve that equals to cosine 2x, comma h, it doesn't give you a very, very fancy result. So it's even more complicated. So I would rather using the guess and check method. Okay, moving on. Okay, state the value of a such that GAX equals to f of x for all x. Well, the a value is just 2, I suppose. Now you need to find an antiderivative of GA in terms of a. Well, just use your CAS calculator. And use the definite integral to show that the area bounded by GA and the x-axis over the interval 0 to 2a pi is equal above and below the x-axis. That means the area positive parts compensated by the negative part, and eventually the sum of all areas will be 0, okay? The signed area, total signed area is 0. And this is a show that question, an interesting choice. So if I have GAX equals to sine x over a plus cosine a times x, and integrating GA of x dx, and antiderivative, you could put c at the end. My personal habit is putting add c at the end, unless it's the definite integral. So it's 1 over a sine a times x minus a times cosine of x over a. Add c. Add c is optional. Now using the definite integral, well, from 0 to 2a times pi, GA of x dx. That gives you this value. And then remember, a is a whole number, okay? So a squared will also be a whole number integer. And sine 2 times integer times pi is always 0. Something along these lines. Okay. What I'm going to do is this is our purpose. So let's try 0 to a pi GAX dx. This is the definite integral. And I think the result we used from part EI is this thing. Now we don't need to put plus c, but we put 0 to 2a pi here. So now the CAS calculator tells us it's 1 over a sine 2a squared pi over a, but I will still use some sort of substitution. 1 over a times sine 2a squared pi minus a times cosine of 2a pi over a, 2 pi. Subtracting 1 over a sine 0. This is indeed 0 minus a cosine 0. So basically, this is a 1. This is a 1. So they will cancel each other out. And this is a 0. So you must have 1 over a times sine 2a squared pi. How would you argue this is 0? Well, you say for a equals to, don't just sub in one value. You have to say a is a positive integer for all values of a. 1, 2, 3, 4, 5, dot, dot, dot. That is a squared. Oh, sorry, that is a. Belongs to a z plus. Sine 2a squared pi must always equal to 0. Therefore, the positive and negative regions will compensate each other. That's not too much working for 3 marks. Show that question. I think a fair allocation is showing your antiderivative with suitable limits. Well, the question says a definite integral, so this is a compulsory thing to show. And the next thing is some convincing working to get that. And then the final thing is, how would you argue this is 0? And you don't actually want to, let's say, put a 1 here, because that's just one value. You have to use 1, 2, 3, 4, 5, dot, dot, dot. It's a continuous pattern for all these values. This term is 0. You have to have a correct argument rather than 1 or 2 values, okay? Okay, explain why the maximum value of GA cannot be greater than 2 for all values of A, and why the minimum value of GA cannot be less than -2. We need to use the addition method. Now, GA of x equals to, well, what's the function here? Sine x over a. Sine x over a plus cosine of ax. Now, sine of x over a is bounded between -1 and 1. Cosine a times x is bounded between 1 and -1. But the maxima of two components don't appear at same x. So do the minima. I mean, the component means this part and this part, okay? Therefore, it's strictly speaking, it's 1 plus 2 gives you sine x over a plus cosine a times x is larger than -2, but less than 2, okay? Because they can't have the same maximum or minimum at the same x value, okay? Something along this line, okay? That's just for 1 mark, so probably you need to show some addition here. And this is the last part. Well, the greatest possible minimum value of GA using the slider method. What's the intention, I suppose? So let's say you have sine of x over a1 plus cosine of a1 times x. Create a slider for a1. Now you can see if a is equal to 1, the minima, all the minimum turning points will have the minimum value minus 1.4142, which is minus √2. Well, technically speaking, let me show you. Sine x over 1 plus cosine x. You could use t collect. And that's how you get, the minimum value √2. But the problem is once you get 2 here and 2 here, it doesn't allow you to collect two trig terms into one, okay? So you can see, okay, if it's 2 here, well, this is the problem. You can see the question has the ambiguity. Do you want the greatest possible absolute minimum value or the greatest possible local minimum value? So you can argue, well, analyze graph minimum. Well, this thing is not as large as, minus √2, but this one is larger than √2, and it's even closer to the x-axis. That's why I think this is where the ambiguity arises, okay? And anyway, if you choose 3, you can see this one is even closer to, closer to the 0, okay? And if you choose 4, okay, now it's fluctuating, but you can still get something like here. You can see this minimum is very close to 0. And let's just delete this point. Anyway, just delete this point. Let me try if we have a very large, let's say 100. You can see the pattern is fluctuating. So then you have to really zoom in. Let's say, let's try a viewing window. Minus 0.1 to 0.1 whatsoever. Now you can see if it's 100. Well, you can zoom in enough. Maybe I can try 200, 200, 300, whatsoever, okay? And you can see, analyzing the graph, the minimum. It's giving you -1, okay? -1. So how would you argue? How would you argue what's actually happening, okay? So anyway, let's just assume the question is asking for the greatest possible absolute minimum value of GA. So the answer is minus √2, okay? This occurs at a equals to 1. Anyway, this is my full explanation to the 2021 VCAA exam 2 math method. Hopefully you find it useful, and all the best for your math method exams. I don't think I'll be able to make other recordings for any other math methods paper. So I'll see you at a later stage. Bye.